There are no staples. Gasp. I have staples over here. All right, chat with your teammates about how to graph these situations and what is different between the first one and the second one and the third one. They each have something different than the other ones.
Did we do this yesterday?
Yeah, and yesterday I said we'll pick this up right here tomorrow.
Oh.
So if you already graphed these, great. Whole thing. For A, Anna, for A, where would I start, quote unquote? You can always pass. Take 90 seconds, actually 85. Do this if you have it. Talk with your team. You should have 3 things graphed. If you don't, we're going to do it together.
Harmony!
That's fine. Let's just do this on here. So you have to put 3 on
Okay, yeah. Yeah, I agree with you.
So, if any of us are stuck, sorry, you still have a minute. A would start, quote unquote, start at a positive 1, since that is the y-intercept of it. And then how does graph A move? What's its slope? It's negative 1, right? So the number in front of the x, which remember there's always a 1. Guys, have we talked about saying 1 is sometimes awkward? Like, did I talk about how if Anna walks in and I say, good morning, 1, Anna? Like, that's weird. I would just say, good morning, Anna. Right? So we don't have to say 1, but this is a negative 1. So as we move, we go down 1 to the right 1. I believe we had this from yesterday. And then we can connect those with a line.
Wait, but you wouldn't say hello, Anna.
Well, if there were 2 of her, then maybe. If she had a twin. So, Max, ironic that you're jumping in because your card is next. Where would I start, quote unquote, for graph B?
For graph B, so 0.5x, so first step 0.5.
Wait, what? 0.5x?
I mean 2.
We start at the y-intercept. So we start at a positive 2.
And then you go 0.5
Yeah, now this, again, I'm going to die on my hill of I don't like decimals. I mean, actually, I shouldn't say that. It's not that I don't like them. Fractions are just better. When we're talking about slope, saying a slope of 1/2 makes more sense than saying a slope of 0.5. Because this, as we talked about yesterday, is rise over run. If you need to make a note on your paper, we use that triangle y and the triangle x because we said that is, what's the triangle? Delta means change in vertical, the y is vertical, and change in horizontal. So I go up 1 over 2, that makes a little bit more sense than trying to go up 1/2 and over 1. Right? This is how this line should look. Hey, the office staff has like 600 people to try to learn their names of, so let's give them a break. And then we could connect them with a line connecting tool. Oh, wait, you don't have a line connecting tool? No. So get a ruler. It's like when we're actually doing this and you actually care for your lines to be nice, get a ruler. And once you have 3 points, you can make a line with 3 points. I would advise you to do 5, though. Once you have 5 points, it's pretty safe. And you can do a lot more than that, too. You can do it with 1 point. 2 points, you can do it, but it's kind of sketchy. All right, now here's the trapdoor. And this is why this is a perfect lead into today's lesson. because today's lesson is called Graphing Trapdoors, or Trapdoors in Graphing. What is 0 squared? Well, okay, 0, right? But then, oh, minus. Minus. Ooh, we got a minus here. That means I got to start negative. So we're starting at -4. 1 when x is 1. What is 1 times 1? 1. Oh, that's silly. -4?
-3.
-3. What's 2 times 2? -4? Ooh, whoa, that's a jump. When x is... Huh? When x is 3, what's 3 times 3? 9 minus 4? 5. Talk with your team. Do the negative x's. Talk with your team to do the negative values of x. So I'm out of these. I appreciate you just drew it on the paper. I'm out of these handouts. So it's probably not right. That's the issue. The math line is not here. What is -1 times -1? +1.
I think you'll like.
I have no guess of where that would be.
Oh, you like that.
Well, she's gone. She's heading to the pot, I'm sure. So, guys, this should be here. And -2 times -2 makes +4 minus 4 should be at 0. And then it's like a V. But actually,
to the office.
it's like a U. So it doesn't have a harsh, pointy bottom. It's got a curve, which of course it has to bottom out somewhere. But it's not a dramatic, harsh, pointy bottom. It actually curves at the bottom. There is a different type of graph that has a point at the bottom. We haven't learned about it yet. It is not. This is a parabola. So if you would like to give it a name, it is a parabola graph. Parabola is how it's spelled. It is spelled parabola. Alright, groups with 2. Oh my gosh, that's hilarious. Whoever dropped. What? It's got math on it. Okay. That was just silent board game math. It's okay.
That was my fault. I put it up.
Alright, so your groups of 2. You'll probably each get 2 and then trade. Alright, you gotta listen to my directions. Like, if this is gonna work. Because I'm trying things differently than I've done before, but, you know, potential for failure. I wanted to make this activity a little bit more fun and make it so that you guys can all be working at the same time. So, our activity is, shoot, I'm actually ahead of myself. We got one more problem to do before that activity. So I'll have time to prep things a little better. Alright, so today, our lesson is called Trapdoors in Graphs. Really, what CPM calls it is graphing errors, but I don't like the word errors. Because it's not that we're making a mistake. What we're looking for are the trapdoors so we don't fall in them. Right? We're gonna find the trapdoors and like make sure that we're all aware of them. So I want you and your group to answer these 3 questions. What is the perimeter of this shape? We call this a dented square, although it's not really a dent. So this is a square. It's x by x. It's our x squared. But what is the perimeter of that? And then on your graph paper, right? Give me your eyes up here real quick. On your graph paper, which is easier than here because you have graph paper, make an x, y axis, but your y is going to be our perimeter. So it's still your y-axis, but we're going to call it perimeter. And graph what happens with the perimeter as x gets bigger. Now, obviously, I think most of us can probably guess, oh, well, it gets bigger. But there is a trap door here. There is a trap door here. Talk with your group.
Oh, you mean that
Man, everything is hard as I can't move.
So wait, here. I want to
I did not. Jake, are you engaging in the activities you're supposed to be engaging in right now? You could go ahead and draw this on your, like, you don't have to, but we're going to make a graph of it, so you could draw the dented square. If you haven't found the trapdoor, you're not done. There is a trapdoor. I don't want you to fall in it.
Do you see how little it is? That literally means the whole.
No, not like, I'm not like being literal and trying to be funny. Like, there's a math trapdoor.
I know. What?
All right, Colin McNeil, what did your group get as the perimeter here? 4x plus 2? So, x, x, x. So wait, this, hold on, are you
Oh no, I know what trapdoor is.
This is part of this. And those red sections together are x minus 1, right? Because we're missing this. But then, Colin, what happens here? That's plus 3. So negative 1 and positive 3 get our positive 2. And this x does still exist, right? Even though we were taking something away from it, it's a positive x. So 4x plus 2. So now, if you haven't done this yet, please go over to a graph on your graph paper, and let's graph this. Where, I think I got lost. I had a thing in here, but I think I put it in the wrong place. Aha. You have this graph?
What?
You have this graph. I said you have this graph. What happens to the perimeter as x changes? Yeah, I literally stood up there and said graph this. Do I have to come invite you like individually?
How do you know what X is?
X can be anything. You can make x1 or make x2 or make x3 or make like.
Every X has
Is there a trapdoor? That's actually not a trapdoor. That's a good observation. It's not a trapdoor. No. You just haven't found it. If we go to graph this, where do we start? 2. And then our slope, if we make 4 into a fraction, it's 4 over 1. So guys, even if your graph is wrong, please don't take time to erase. Just do it correctly. So we go up 4 over 1, up 4 over 1, up 4 over 1. Yeah, except.
Oh God, he's sitting down.
Sitting down.
Oh God, it's here.
It's what you like.
My mom died.
This is wrong. It's wrong. Because this is impossible. Remember back very, very beginning of school when we talked about what's impossible?
No. Nothing.
Something up here, not in math, there are things that are impossible. Something up here is it's silly, right? It's like, oh, silly goose. Like, we can't talk with your team about what you just said. Like, so this point right here, right? That point is at 2, 10, I think. What does that point mean? What would this point be? What would this point be? What do those points mean? And hopefully we can kind of find the trapdoor here.
Wow, guys. I'm also.
Two confused people working as a team. That can't go wrong. Is that possible?
No. Are we saying that?
So
Wait, how is it not possible?
this is wrong.
No. It's
Yeah.
What is that?
When X is, right? So, guys, don't worry if you feel a little like whatever, that's on purpose, because that's when the best learning happens. So we have this square, it's dented. It's okay, we still love it. So our dented square has a perimeter, we said, of 4x plus 2. So we wrote out, okay, our perimeter is 4x plus 2. Sure.
I know the problem. I'm confused.
So this point means when I make x equal 2, that causes the perimeter to be 10.
Yeah.
Yeah, hold on. So if this is 2, and this is 2, and this is 2, and well, this will it'll look wrong right now, but this would be 2 but minus 1. So between this piece and this piece, it'd be like 1, right? So I could say like 3/4 and like 1/4 maybe. And then the 1 and the 1 and the 1. 2, 4, 6, 7, 8, 9, 10. Yeah, 10. That works.
No, stop it, you and your
But-
fancy mouth.
But the graph is broken.
How?
Talk with your team. 60 more seconds. 1 more minute. Try to figure it out. Why is the graph broken? And that's not what we mean about the graph being broken. It's just broken like it's broken. It's just wrong. It's just broken. Here, I'll try to appease you. Here, if I move my dent to the very middle, and we say the dent is always the middle.
You really should.
I am.
I get it now. Max gets it. I don't get it.
I get it.
So then,
Then it would be a half and a half.
yeah, so then a half and a half, right? So
No,
that doesn't work.
No, it's not.
yeah, if x is 2 and this is 1, because these are 1s.
You and your fancy mouth.
Hold on, we can't all talk at the same time.
You can't have bigger than the one.
What do you mean it can't? So this from here to here needs to equal 2. And if I do half, 1, and half, it does equal 2. This is not what's broken. I know you guys are searching for what is broken.
Oh, well, never mind.
What's this point?
That's 1 and 6.
So
How is it 0? 1
Aiden, say what you're saying, but louder. Wait, well, I mean, it can. We're gonna have to mop up the brain bits off the ground in a second.
No!
Aiden, say it again, but like go slow for us that haven't figured it out yet.
One can't take away from itself and still have a parameter. It just turns into 0.
If the sides of my box are x and I make x 1, all of a sudden my dent is the entire length of x. And is the entire length of x. And my dent is now the entire box. Which means it's gone.
Yeah.
Also, hold on, we'll come back to this point. Also, when we went to the graph and we said start at x equals 0, can I make a square with side length 0? No, it's impossible. Right? Not like, oh, it's really hard. Like, no, it's just impossible. That's not a shape. Like when somebody asks, like, oh, can I get a paycheck? And I'm like, oh yeah, I'll double what I paid my students last year. Like, it's nothing, right? Like, if the paycheck is nothing, you're not getting a paycheck. It's nothing. So, wait, so what we're saying is, in this graph, this point doesn't exist. It just can't. And we said this point, our perimeter actually turns into 0.
What?
Because that's what Aiden said, because if x is 1, we can't trust this anymore. If we come back here and think about 1, 1, 1, minus 1, minus 1, like, it's got, the dent is now the side. So this point, hold on, I'm going to show you the secret here. Here's what we do. Here's what we do. We still graph that. If anybody else would like to come up here and teach this, you are more than welcome to. Otherwise, I know more than you. Be quiet. Do you know what I'm going to say?
Yes.
I don't know if you do, but okay.
What was that laughter?
No, thank you for that.
Magic. Why should your G like that?
Could x be 1.1?
Yes.
Could it be like 1.2, 1.3? Yeah, just like 1 breaks it. Here's how we show that. So as Lily over there, which when I was a younger teacher I would have like gotten annoyed, but actually it reminds me of something to say, so thank you. X can be, do you want to say it?
What did I say? Oh.
X starts at
I don't remember saying that.
somebody over there was saying 0, 0, 0, 0, 0.
That was me. That was me.
As long as x is bigger than 1, doesn't matter how much, it's allowed to exist. So, here's how we graph it. Fix your graph. We make this an open circle.
Oh, no, I hate it.
Because it's not a point.
Oh, goodness. You put it at the 5.
Did I? Yeah.
It looks like an eyeball.
And then, guys, this is gonna end up on a mastery. It's like maybe even Friday, because I haven't written our mastery for this week yet. And then we graph our lines starting at that empty point. And it ends up being a ray, because it would not make sense for x to be negative. Or you can't have a negative sideline. Alright, this next task is going to be difficult because some of you can't go 10 seconds without talking. I have 4 broken graphs. Well, they might be broken. Wink, wink, nudge, nudge. I'm going to drop these at your table group. Each of you take one and figure out what's broken with it. When you're done with it, put it back in the middle and take a different one. There are 4, so there will always be an extra. If you only have 2 people in your team, there will be more than 1 extra. So, we do not need to talk because here's what I want to see. I want to see if you each identify the same thing that's broken about each graph, or if you identified some different stuff. So on your paper right now, I need you to number, I don't know why they did this. Double I, triple I.
It's like there's only 10 questions.
And then either quadruple I, or you could do an IV for Roman numeral.
Oh, but this should be
Well, the video will exist later, or you can just ask a friend. If you can't figure out anything that's broken, I don't know, maybe it's not broken.
Oh.
You can't figure out anything that's broken, maybe it's not. You're figuring out what's wrong with the graph I just gave you.
You made this so like
Yeah.
Can we write on this?
Yeah, sure. I mean, I'd rather you be writing on your graph paper so your teammates don't see it, but if you want to, like, draw on it.
Oh, okay. Look at the football.
Well, you haven't seen it.
Probably.
Okay. So, anyways, for this one, like, do you need the lines there? Because, like, I know they're with them.
Yeah, there's one other piece of information you guys are missing. These graphs came from Mrs. Chang's class. These graphs, you are grading your classmates. This is the data they have been asked to graph. You mean P, 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 P. Progressing. You're trying to say that they get Fs. So this is the data they're graphing. When you are looking at graph I, this might help you figure out what is going on. I would like you to go 90 seconds without talking. That's a pretty low bar. Write down on your paper what is broken about the graphs. Then pass it on to somebody else. Make a guess of why that student did that. Yeah, so go and write that down. That's why it's broken, right? So if you were the teacher trying to give feedback to these kids who made some messed up graphs. So do I. Or not X compared to Y. You can do 2 different scales, X and Y. So think about what if like X was time and Y was like temperature. Like there's a lot of situations that make us use different scales. Ooh, but if that's the data that we're trying to graph, and this is what the kid like set up, will it work? So why won't it work? So wait, before I showed you the data that they're trying to graph, some of these graphs we couldn't tell if they were broken or not because we don't know what the intention of the graph is. Right? So we always need to know like what's going on in order to determine if a graph is good or not good. So their data, I'm going to try to copy it real quick and get it down by the thing. This is the data they've been asked to graph, and these are 4 graphs that kids made thinking, okay, I'm on my way now. Gotta love random cards if I know where the heck they are. Nevin, in graph I, I'll go ahead and admit there's nothing inherently obviously broken, but can you figure out why it's not right for Miss Chang's activity in class? Okay, so we wouldn't be able to make a line. They've only focused on this first point. They're like, that's it. I'm doing 1 and I'm done. Definitely progressing. What else is wrong with it though?
There's also, I noticed on your, get the name. I always miss the names of lines, like rays and
Yeah.
angles. But they aren't like they don't stop. Oh, there's also no origin.
Okay, they didn't indicate the origin, right? They didn't indicate like 0, 0 or anything there, which we should do, but we don't necessarily have to do.
The lines just kind of keep going.
Amelia?
They mixed up the Y and the
This is your x-axis, but our x is supposed to be 2. Come on. This is the y-axis, but the y is supposed to be 8. They goofed up their xy. Guys, x is always your horizontal, y is always your vertical. So graph I goofed up their x and their y. Huh. Literally just called on you. Russell, what about I? Yeah, is there anything wrong with that guy?
On the x-axis, the point that's near the origin is 2, not 1, even though it grows up by 1 each time.
You're close, but I disagree with one word you said. You said the point near the origin. This 2 is at the origin. And the 5 is at the origin. What should be at the origin? 0. That's not the only thing that's broken. Well, okay. I guess you could make an argument that the rest of it's okay. That if we fix the origin, maybe it's okay. Connor? So the graph, if we fix the origin, the axes are fine. Like 2, 3, 4, 5. As long as I add a 1 in here, right? Fix that. Fix this. But hold on. I'm doing Connor's first. Notice how you raised your hand, but then you didn't wait. So Connor said, we can't get here. This graph ain't big enough. What's up?
Olive and Brooke.
Olive is for sure in language arts because she comes to me next. I'm not sure about Brooke. In triple I, What?
No, Brooks in
whatever.
connections.
Okay, well that's.
Let's just say we walk to class together like after lunch.
Gus, in triple I, what did they do? Oh, sorry. Distracted. Lily, you had something. My bad.
I don't know how to say it, but you see this? Same like as this, which is not good because this is a 10-point jump and this is only a 5-point jump.
What? 5 jumps every time. We're not on.
Yeah, but
scaled
not on
by
this.
It's scaled by 5.
Oh wait,
5, 10, 15.
wait, crap! That's an error too then.
What?
The 5
So-
at the origin as well.
Yes.
Yeah, so what Lily's saying, I'm with Lily. What Lily's saying is if we make this 0 and make that 0, we can't just make, we gotta move everything. Alright, I can't just erase and change those to zeros. I gotta shift all of my y points because if this is 0, it's not 5. Right? I hear what everyone else is saying of it jumps by 5s, but Lily's saying if I make this 0, And this is wrong then too, right? 3-point jump, then 1. That's not correct. In triple I, Gus, what happened?
Well, first, they skipped, 1 second. Yeah, they skipped 4.
No.
Yeah, but so does the table. Table skips 4
Yeah,
also.
but you should still include it, I feel like, right? Or else
Well, yeah, we
they-
definitely
they
would
only
need
have-
to.
they
Renal?
only have the points, not consistent.
What's that, Renal? Everyone else was talking. Yeah.
They put the scale, they just use the numbers of the table. They actually have going by 2.
Yeah. They were like, oh, well, if these are the points I want, they're the points I'm going to make, and then it's going to be right there, right there, right there, right there, and we're going to make a nice, pretty straight line. That's not how this works. You can't cheat the graph like that. And in quadruple I, Jake.
Where's quadruple I capture? Show me.
Aharon, you want to jump in?
I know what it is.
All right, hey, let him talk.
It's not quadruple
Let- Oh, it's IV. But yeah, let him talk for a second.
Okay, so it is, it doesn't have it starts, there's no 1. There's no so,
Ooh, actually, good point. If this is a jump of 1, then this would only be a jump of 1. This is broken. That is broken. That's broken. But also, can we fit all of our points on this graph? No, they got to make a bigger graph. So not only is it broken, it also won't fit. Are you okay? You look upset about something. Lily, you look like angry at something. Are you just angry at Miss Chang's class and their terrible graphs?
I'm just tired.
That's it. Good work today, guys. That's it. Pack it up and head it out. I probably can't release you yet. I can't release you yet, so hang on just a second. Hold on.